Hello, welcome back. We'll be continuing from where we ended last. This is Meiosis 2, as you can see here. Now over here, what happens is very simple actually. This is same as meiosis. Okay, so we got our chromosomes as 2 over here. Now in the prophase stage, nuclear envelope and nucleolus disappear is normal. Okay, this is a normal thing. Centrioles replicate and move to opposite poles of the cell. This is also the same thing. Remember that here they have to replicate, because why? They were already one centrioles over here, because we had two, right? Remember, we had two centrioles. Okay, we had two centrioles. They got divided, they become one. You can see here only one centriole, right? And now in this step, these centrioles, because it is one, it has to be divided, right, to form two centrioles, and then moved to the poles. Okay, so again you should have these centrioles being replicated in prophase 1 of meiosis 2. Hope that was not confusing. And as usual, nuclear envelope and nucleolus again disperse. Here we know that in the meiosis, so in the prophase stage they disappeared, and then they were not there at all, and then they formed in the telophase. And in meiosis 2, in the prophase stage, again they have to disappear. Actually they disappear for the reason that they give a chance for spinal apparatus to form. Okay, if they are present, the spinal apparatus wouldn't form, and so the chromosome wouldn't divide and all that. So because they want the chromosome to divide, they have to go away and let the chromosome do what they want to do, right? So hope that was clear. And then we have this chromosome line up separately across the equator of spindle. Now we can see what's the difference here in the metaphase of meiosis 2 and metaphase of meiosis 1. You can see the metaphase of meiosis 1, they are bivalent, pairing up, right? But then here, since we don't have a bivalent, we have just one chromosomes. Normally when we don't have bivalence, they sort of will line up like this, okay, across the equator. They line up separately, unlike here they lined up together. Okay, so you should note that very clearly. And then after metaphase 2, we come to the anaphase. Now even in anaphase there is a small difference between these two, as we can see here, right? Centromeres divide and spindle microtubules pull the chromatids to the opposite poles. But here centromeres do not divide, unlike in mitosis. Now you can see the difference, right? Here what the thing is, here we have like structures like this. In this case we have structure like this. Let me just take a black ink. Okay, here we have structures like this. Okay, and then there is another one. Let's say this one is maroon. Now we know that these two normally are bivalent, right? They are bivalent. So when they divide, their chromosome, their centromere, let's say their centromere is pink color over here, and this one they have their centromeres here. These centromeres do not need to divide. These just go direct with the cell, and this one goes direct. Okay, but in this case, if we have maroon, since there is just one, and since this itself gets divided, we do not have pair, we have single chromosome. Okay, individual chromosome having lined up, as we saw, this is single chromosome lined up in the equator. So we have just single chromosome lined up. So what happens is this this chromosome now starts to divide. It goes to the opposite pole. So one side goes here and the one side comes here. So we can see that our so-called centromere half went here and half went here. So centromeres divide in anaphase 2. Okay, so hope that was very clear. And then the final stage, this is the same thing. This one forms constriction. Okay, there's a constriction, cytokinesis, but just the one difference is that there are 4 haploid daughter cells. Now why 4? Because of the same reason. Look, maybe again I should summarize this. This can get daunting sometimes, but if you're confident and if you understand this topic well, then it won't be daunting for you. So let me just show you why 4. As you can see here, there were 4. Let me just use a good ink. Okay, let me use blue. You can see there were 4, right? They didn't replicate. So 4 again. Okay, they didn't replicate. They sort of lined up in the equator as bivalent. Again 4. Okay, again 4 over here. So the initial one was 4. Okay, so you got again 4. Then in the anaphase stage, they sort of divided. The bivalence pair divided. One went up, one went down. Okay, in each pair, one went up, one went down to the opposite poles. Then each pole had its own cells produced. Okay, so there are 2 cells produced, new cells produced. So we got 2 cells. Okay, each one with 2 chromosomes. And then we went to meiosis 2. Meiosis 2. These 2 again, they were there as usual. They remained. There was a replication over here. There should be replication in this stage, right? Because okay, so no, actually there is no replication in this case. Only replication takes place only in only centrioles replicate. There is no chromosome replication in meiosis 2. So don't get me wrong. I just confused this with the mitosis. I think mitosis is the one that has replication. Over here there is no replication. This 4 divide here to give you 2 and 2. Okay, so this 2 and 2 remain there, and then again this 2 over here. Oops, yeah, these 2 again. There are 2 chromosomes. Now each chromosome pair divide. Each chromosome divide to give you a haploid, a single chromatid going to the opposite poles. Okay, so eventually you get your 2 chromatids here, 2 chromatids here. So this normally pair up as 1 chromosome. Okay, if you pair up, so these are 2 chromatids, and so you get 4 chromosomes with just 1 this. So it's simply this one. Since there are 4, it happens to be there are 4 cells, each with 1 of these. Okay, as simple as that. But then the process goes on such that in long process. But what eventually happens is from this 1 cell we get 4 cells, each one with 1 of these chromosomes. Okay, so that's all about meiosis. Hope it was clear, and thank you for listening.